chance to work with a lot of really cool technologies. And today I'm going to have the pleasure of telling you a little bit about machine learning. So at Google, our mission is to organize the world's information and make it accessible to everyone. Data is at the core of what we do, and increasingly, machine learning is as well. When I talk to a lot of customers like you, companies all over the world, I find that increasingly data is becoming essential to everything that we do. If we think about any industry, any company, we need data about our customers, about our products. We use data for competitive advantage. And really, being able to use data is what's going to make companies successful in the future. So what is machine learning, and why is it important today? So at the core, machine learning is about creating intelligent applications. It's made up of three main components. The first one is data. You need data, and lots of it, in order to be able to train a machine to do intelligent things. You also need algorithms. There's a lot of different types of algorithms used for machine learning, from regression and clustering to support vector machines and neural networks, and many more. And then you need predictions, right? Essentially, a prediction is when you run a model, for example, to classify a specific object into a class. And if the machine can do it right, you have a successful model. Now, in order for machine learning to work, you really need a lot of data. And you need to try different algorithms and see how your predictions fit or not fit your training set. And at Google, we've developed a lot of technologies to help you do machine learning with all of these things, right? If you think about using lots of data, well, you need infrastructure for that. Trying a lot of algorithms, you need compute power for that. Running predictions, batch or online, you also need compute power for that. GCP, we've developed technologies to help you with all that. So we've been using machine learning at Google for many years. During the keynote, Miles talked about how today we have over 1,500 different projects or products at Google using machine learning. And the growth has been exponential. Like literally a few years ago, it was really only Google Search that was using machine learning. We began introducing image search, which also took advantage of machine learning. Today, pretty much every product that you use at Google uses machine learning. One of my favorite products is Google Photos. Google Photos allows you to automatically upload your photos into Google Cloud. And we can automatically label your images. So for example, when you want to search for images that contain a pool, we can give you all the images that have that. Pictures with a woman will give you that. Beach, even recognizing landmarks, recognizing sports, recognizing all sorts of things. So when I want to show someone pictures of my son playing football, all I need to do is search for football and my son's name, and I'll get exactly those. I'm also I coach a middle school robotics team. So I want to show someone a picture of that. I'll just search for robot, and I'll get all the pictures immediately. And that works for any kind of images that anyone has. How are we able to do that at Google? Well, because we've trained models to do image recognition with literally billions and billions of images. And we've tuned those models in order to be able to make them available to every one of our customers. Another example that I love is Google Translate. Any of you have used Google Translate app? Wow, fantastic. There's actually 1 billion people who actively use Google Translate. Google Translate allows you to translate from any number of languages, dozens of languages, to any number of languages too. So when you go to a foreign country, you can literally point the Google Translate app, and it will even translate signs in place, or a menu in place. How do we do that? It's a very complex model. In fact, it's 7 different models. When you do the full image translation experience, that includes detecting, letters that are in a specific image, detecting what characters they are, what language they're from. Then, depending on the language that they're from and what language you're translating into, then there's different models for each language pair. And then ultimately getting the results and then putting them back into the image. 7 different models all stacked up on top of each other. Amazing what technology can do. Now, when we look at how to deploy machine learning, there's really a whole spectrum of different classes of applications and technologies that you can use. So at the low end, if you will, there's building your own machine learning models from scratch. And we have a technology that we open source called TensorFlow that allows you to do that. There's also many other open source technologies that allow you to deploy machine learning models, such as Spark MLlib. So if you want to build your own machine learning model, you might be a researcher, you may be a data scientist, you're comfortable working with a lot of data, understanding abstract models, translating them into code. You're comfortable building your own infrastructure, maybe deploying, training those models on your own cluster, and so on. So that's good for some people. At the other end of the spectrum, we have application developers who really only want to get access to machine learning models that someone else has trained. For example, to be able to do image recognition or speech translation to text. And then in the middle, we have people who are somewhere in between. They want to be able to build on technologies to train models, but they don't want to have to deploy their own infrastructure. So the key 3 technologies that I'm going to talk to you about that we offer at Google are TensorFlow, which allows you to build your own models, cloud machine learning, which allows you to train and run those models in Google Cloud, and then machine learning APIs that allow any application developer to be able to get access to machine learning models. So let's start with TensorFlow. So we open sourced TensorFlow about a year ago. TensorFlow is basically the core technology that we use at Google for our machine learning applications. We open sourced it, and we actually thought initially that we would see good adoption from a community of researchers, but we never expected how popular it would become. In fact, in a matter of a few days, we already had tens of thousands of downloads of TensorFlow. And today, it is the most popular machine learning open source project on GitHub. It's been used by a lot of different people in a lot of different scenarios. So TensorFlow is essentially a framework for numerical computation. It is really, really good specifically at doing matrix operations. And a lot of machine learning algorithms depend on matrix multiplications, additions, subtractions, etc. Essentially, TensorFlow, the name itself, comes from 2 things. One is that it operates on tensors. A tensor is an n-dimensional array. Think of it like a matrix, but in multiple dimensions. In some cases, it may be hundreds or thousands or tens of thousands of dimensions. And the second part of the name comes from the fact that TensorFlow allows you to define flow graphs. Think of it, for example, as a neural network where the data is flowing through a network, converting your inputs into outputs. Your inputs could be, say, speech, an audio file, and your output could be that speech translated into text. But it can also be used for many other things, for example, regression. You may be trying to do product recommendation. So when someone comes to your website, figure out, hey, if they've selected a specific product, which other products are they likely to get? You may represent that using a model that it's all based on numbers, ultimately. And you define a flow graph that TensorFlow is very efficient at executing. TensorFlow runs on a wide variety of hardware. You can run TensorFlow models on a mobile device. In fact, for any of you, if you're Android developers or iOS developers, we have samples on the TensorFlow side that allow you to run TensorFlow models on your mobile phone. You can train new models on your laptop. But sometimes when you train models on a laptop, it can literally take days to train a model, especially if it's a very complex model, because machine learning uses a lot of computation. So a lot of people may deploy TensorFlow in a cluster, or even better, as I'll talk about later, run it on cloud machine learning on GCP. So this is what TensorFlow code looks like. So on the left, we have a flow graph. It is basically a very simple neural network that does matrix multiplication, then adds another matrix, and then that gives you a result. So essentially, when you're defining your code, you define the network itself, defining your variables, defining your placeholder for input, defining the model itself, and then you run training on it. Essentially, what training means is that you take your data. In this example, we take basically data that represents a series of inputs, and then we calculate what's called a loss function. You're trying to minimize that loss function, and then you iterate over it multiple times till you ultimately get to your result. So let's actually take a look at this in action so you see what it looks like. So I'm going to run you through a model that allows you to do recognition of handwritten digits. It's kind of like the hello world of machine learning. It's actually a very well-known data set called MNIST that has 60,000 different handwritten digits. And it's used as a benchmark for different kinds of machine learning models. So what we see here is a Google Cloud Data Lab notebook. During the keynote, you also saw a demo using Cloud Data Lab. Cloud Data Lab is an interactive environment that data scientists or data engineers or any developer can use to work with data, to use any number of open source standard libraries, and of course, including TensorFlow. It's also the environment that is used for cloud machine learning. So basically, you build your model here, and you deploy it into cloud machine learning. So in this example, what we need to do is to build a model to allow you to detect what digits we have, like 5, 0, 4, 1. So MNIST is based on data sets that are publicly available, where each of the digits, 60,000 digits, has been encoded into a 28 by 28 pixel matrix with essentially a grayscale representing how light or dark each pixel is. So the first thing that we're going to do is we're going to load the training data. Training data is actually stored on my laptop, but it could easily be stored in Google Cloud Storage or in BigQuery. So I'm going to run this, and basically it's extracted the data. It's about 60,000 images, so it was pretty fast to do. But there are machine learning models that could use, obviously, terabytes of data. Then what we do is we declare what's called a placeholder for inputs and variables. Essentially, we're going to build a model, and we're going to be, as we train the model, we're going to be loading each digit, each image that we have into a variable. So the variable itself is called x, and it's a TensorFlow placeholder that is 784, basically 28 by 28 numbers between 0 and 1. And the first dimension says none because it basically means any. So it's going to be any number of inputs that I have times 784. Then I'm going to build my flow graph. And essentially, this is a very simple, pretty much the simplest neural network that you can think of, where you have many different inputs, as many inputs as images that you have. Each input has 784 values, 28 by 28. And we want to get to a series of outputs, which essentially is what's called the label or classification. So we're going to be classifying basically each one of those images and figuring out what is the probability that it is each of the digits. So for example, an image that looks like an 8 probably will have a very high probability of being an 8, but maybe it could also be a 6, maybe it could be a 0. So we're going to see different probabilities. So what the model essentially looks like is we take those inputs, we multiply them by weight matrices that essentially tell me for every pixel how likely is it that it belongs to a specific class, in this case a digit. And then we add what's called a bias, meaning that some pixels are more likely to appear in general for specific numbers. And then we apply what's called softmax. Softmax is just a function that allows you to translate the output of a neural network into a set of probabilities. So we get probabilities for each one of the digits that add up to 1. And the way we define this matrix in TensorFlow is pretty simple. I mean, basically, we define our weight matrix and our bias matrix. Our weight matrix is 784 times 10, 784 pixels times 10 potential classes or labels. And then the bias is just 10. Basically, each class has a value. Then the model itself is literally just one line. So we basically just say y, meaning our output, is basically it's a softmax, which is a TensorFlow function of matrix multiplication of x times our weight matrix plus b. Now, these are all tensors, right? Each one of these variables is a tensor and multiple dimensions. So this can get complex pretty fast. But fortunately, TensorFlow makes it pretty easy to do. Step number 4 is because we are training our model for each one of those images, we already know what digit they represent. So basically, our variable y underscore is where we're going to put the actual values. So as we're building our model, we're essentially figuring out the right weights and the right biases to do so that we get as close as possible to the correct labels. And then finally, every machine learning model has what's called a cost function or a loss function that allows you to measure how close is the output of a model to the actual values. And in this case, we're using a cost function called cross entropy. We could also have used the sum of the square of the differences. And then finally, we train the model. So now, at this point, the only thing we've done is we've built a flow graph. So our variables are basically just placeholders for the actual data that we're going to have. And then we're going to train the model. We're going to use a gradient descent optimizer. A lot of machine learning models use that. That basically means that as we're training our model, we calculate the derivatives, for those of you who know calculus, and then we try to move towards the place that has the highest derivative so we can converge to the optimum value as fast as possible. We initialize TensorFlow, and then we run 1,000 training steps. And by the way, this is all Python code. We can actually run this, and we're going to see how quickly we converge to the optimum value. So we're going to run to this cell. So here we are. We're running 10,000. We're running 1,000 different iterations, and we can see how our model actually starts with a very low accuracy, meaning that it's only able to predict initially 40% of the correct values. And by the time we're done, it's closer to 91%. So after we run the model, we can evaluate it with a different data set, or training set, a test set, and we see that the model was accurate 91%. So 91% is actually not that sophisticated. It's actually pretty low. But our model was incredibly simple. Right? With TensorFlow, you can build a lot more complex models. And in fact, if you go to tensorflow.org, you can see what we call an expert sample that actually can get into 97% or higher accuracy. OK, let's go back to our presentation. OK, so basically what we can do with TensorFlow is we can simplify a lot of the process of deploying a machine learning model. But we can do better than that. If we run the model in the cloud, then we can save even more steps. So when you run cloud machine learning, essentially what you get to is you can easily design your network, right, your neural network. You can train maybe in a single machine, just to get a sense with a small data set. Then you can train on the cloud. And once you're on the cloud, you can train with a full data set, right? A data set that could be gigabytes, terabytes of data. It could be stored in BigQuery or in Google Cloud Storage. And then you can run your prediction in the cloud. And by running your prediction in the cloud, which can be batch or online, you can then access it from any kind of application. So let's talk about machine learning, cloud machine learning in more detail. So cloud machine learning is a product that we just recently announced. It's in public beta, so anyone can use it today. And essentially, cloud machine learning, or cloud ML, is a fully managed service, so very similar to other services that some of you may already know about, like BigQuery or Dataflow, in the sense that you don't have to provision specific capacity. Right? Cloud ML will grow depending on what the needs of your model are. With Cloud ML, you're basically training a custom TensorFlow graph that you define. We have a lot of samples available, so you can customize those samples or build one from scratch. Cloud ML allows you to run both batch predictions and online predictions. So batch predictions, for example, could be if you're building a model for a marketing campaign, and you want to find out who are all the customers who should be getting a specific email, you could run a batch prediction model and then select those customers and send them the email. Online would be, for example, if you want to give product recommendations to your customers as they're visiting your website, they click on a product, you want to recommend other products that they may be interested in, you could be running that model online. Cloud ML supports both of them. It supports both regression and classification tasks. Regression would be used, for example, if you want to do forecasts. And classification is like image classification or classifying a customer into likely to buy new products or not. And as I mentioned before, and I showed you in the example, it's fully integrated into a Data Lab notebook experience. So from Data Lab, you can access any data that you have in GCS, in BigQuery, in Cloud SQL, in other data sources, and then be able to build your models, run them, pre-process all your data, and then run your models after they've been trained. So to use CloudML, the first step is to have data, data for your business. And one very important thing is that your data has to be labeled or pre-processed so that it's ready to be used in training. So for example, if you're training a model for product recommendation, you probably will have a big data set with information about what products different customers have bought. Right from there, you could train a model, and then you could run predictions after that. If you're doing image classification, you're going to have a lot of different images that you would have labeled, and then you can build models based on that. So let's take a look at a specific use case. This is from a Japanese company, one of our customers called Augment. So Augment operates the largest network of used car sales. And essentially, what that means is that there's about 30,000 used car dealers who basically participate in the network with Augment. And one of the big things that they need to do is to figure out, when a customer comes in with a used car, quickly figure out what kind of used car is it, what model, what state is it in, how much is it likely to be sold for, and then put it up on the auction site online to be able to sell that car. So what Augment wanted to do was to figure out from a set of images about the car, basically what car is it, what specific model is it, and what part of the car does the picture represent. So they started with a bunch of images. They collect over 1 million images per month, and they have specific labels. So they already had a bunch of images for, say, a specific Toyota brand or a specific BMW model. From there, they have a question, for new images of cars. They want to be able to classify what specific car part is it, and then ultimately also classify into the specific car. So what they want to do is run a trained classifier. So given a specific image or set of images, tell me what parts of the car they are and what's the model of that car. So essentially, this translates into a lot of numbers. They basically have a lot of images with a lot of numbers, and what they did was implement a process using TensorFlow and then cloud machine learning that takes the features, meaning all the numbers for each of the images, pre-processes those images, builds a TensorFlow graph, define the hyperparameters like the learning rate and the number of training steps, and then package that TensorFlow graph, send it to cloud machine learning. This is all done using Data Lab. And then cloud machine learning can run the model, train it, and then they can run predictions. And once they have the model, they can run those predictions very simply, through an API. Therefore, they can run it from any application. So let's actually take a look at that in a demo. So this is the actual website for this application. And the way it works is that I can upload images of a car, and we're going to see how it works. I'm going to upload images of a car that I have. I'm going to open. And essentially what the demo is doing, it is uploading images. As it's uploading every image, it's actually figuring out through the model what part of the car it is. So the first one is a dashboard. The second one is a right side rear with a certain probability. Actually, most of the time is taken by uploading the image. The classification happens very fast. So we're uploading all images, and once it's done, we're going to see how it has classified each of these images into a specific part of the car, and then we're going to be able to see what car is it. And voila, here we have. So it was able to deduce, from the pictures, hey, this is the right side with 96% probability. Here's the rear tire, 95% probability, etc. And overall, 89% probability that this is a 2012 Toyota Land Cruiser with expected value of $39,000 or more. So you can see how this can be applied in action, and you could apply this, in a lot of different for a lot of different industries and use cases. So with cloud machine learning, you can take your data, which could be in cloud storage, in Google BigQuery, or any other database in cloud platform. Use Cloud Data Lab to develop and build your models, and then run your models in cloud machine learning using TensorFlow. So let's now talk about machine learning APIs. So if you're a developer and you want to take advantage of machine learning, and you want to take advantage of models that we've already built at Google, we have several APIs for you to use. The first API that we have is natural language. So think about any application that you have that has text that you need to be able to parse, you need to be able to understand. Say you're building a bot, right, an automated agent, so that your customers can, rather than call someone, they can directly through instant messaging or through a chat box be able to interact with your applications. Say you want to manage documents where you want to figure out, what's the document all about, say in medical or legal use cases. So essentially, the Google Natural Language API allows you to do all that, and it's based on the same technology that we use at Google, that we use for Google Search. It allows you to detect different kinds of features. For example, all the syntax, what parts of a word, what parts of a sentence each word represents. It can do entity recognition. So if you're looking at an article, say, in the news, it can detect all the important people or the important places and so on. And it can do sentiment analysis. So it will allow you to know whether a text is mostly positive, mostly negative, how positive or negative it is. So if you have, for example, user reviews, customer reviews on your website, you can actually figure out how positive they are. Or if you receive emails, you could classify them. So let's take a look at the quick demo. So this demo is available on our website if you go to the Natural Language API. Let me make this a little bit bigger. So I'm going to write some text here. J.K. Rowling is the author of the Harry Potter series. So we click on Analyze, and essentially when I click on Analyze, it's going to go call the Natural Language API, which, by the way, is just a REST API, so it can be accessed from any number of languages. We offer client libraries for 7 different languages. So we can see here that the Natural Language API was able to automatically detect the entities. In this case, J.K. Rowling is a person, and Harry Potter is a work of art. How many of you think it's a work of art? Yeah? I do. So then we can also look at the sentiment. So sentiment tells us that it's a positive. J.K. Rowling is the author of Harry Potter series, positive with a relatively low magnitude. Now, say I change this into J.K. Rowling is the world-renowned author of Harry Potter series. And what we'll find is that the sentiment has gone up in magnitude from 0.5 to 0.7. So you can see how we can, and this gets actually pretty sophisticated, right? Because this could be a much longer paragraph of text. And we're very sophisticated in how we analyze different words, what they mean, to figure out how positive or negative it is. And then you can look at syntax. So say you were building an application, and you actually need to figure out what's a verb, what's a noun. You can very easily do that, again, based on very sophisticated models and with support for different languages. And all of this accessible through a very simple API. So that's natural language. Now, we also have a Google Translate API. So earlier, when I asked you how many of you use Google Translate, a lot of you do. So Translate API is accessible just like Natural Language API. Very simple REST call, or call from any one of our languages for which we support client libraries. And it will translate text between thousands of language pairs. So basically all the languages that we support, including using some of the latest technologies. For example, we just announced 2 weeks ago that we've deployed brand new neural network models for some language pairs that are especially hard, like Chinese to English and Japanese to English. So those are all available through the Translate API. And it allows you to translate programmatically. So let's take a quick demo of how that works. So this is available on our website. So say I wanted to know, I'm traveling somewhere and I want to know, give me directions to the to the art museum. And I will translate that from English to, say, Spanish. Translate. And there we get the response. So this is exactly what the API would look like. I mean, what the API results. So you can see the API request on top, and then at the bottom, you get a JSON response. And all the APIs that I'm talking about have a similar JSON response, so it's very easy to parse and then integrate into your own applications. OK, let's go back to our presentation. So we can do natural language. We can do translation. But one of the most important things that is happening now is that more and more often, people want to be able to talk to their phones, right? To ask for directions, or to do a product search, or maybe to even converse with have a conversation with a chatbot in order to be able to find information about your products. So we've introduced the Google Cloud Speech API, which uses the same machine learning models that we use internally at Google to be able to convert audio into language, into text. It works across more than 80 languages. And one of the nice things is that it works in both streaming and non-streaming mode. So streaming means that you could have an application that as you're talking to it, it's sending data to the speech API, and we're sending you the results back. Not only do we do that, we even refine the response as you're speaking. Because sometimes, as you're completing a sentence, we may find out that some words that you said at the beginning actually meant something else than what the speech API thought it was. So it's incredibly good. If any of you have used Google Search on a mobile phone, it's basically based on the same technology, that as you are speaking, you can see what the text is, and it's refining it based on its understanding of what it does. It's very sophisticated. It can do a lot of different things. So automatic speech recognition, it recognizes what language people are speaking in. It, again, does streaming. You can also filter inappropriate content, so you can figure out whether someone's saying words that maybe are not appropriate for your website. It can handle noisy audio. This is very important because real-life application, people may be calling your app from a subway. Right, there may be a lot of background noise. So we've trained our models to recognize this, and they're really good at filtering out noise. And of course, if you have a professionally recorded audio with a microphone, we'll do an even better job. But it works in a wide variety of scenarios. And the API works really well with other products like the Natural Language API. It can read data from Google Cloud Storage. So I'm going to do a very quick demo. And we're going to see how this works. And just as before, these demos are all available for you to try later. So I'm going to try to say something. Let's try. The Prime Minister gave a speech last week about Brexit. OK, the demo gods are not working with me today. We're going to try again, and if not, we'll try again. The Prime Minister gave a speech last week about Brexit. See? So I don't know if you noticed that as I was, about Brazil. OK, I kept talking. But I don't know if you guys noticed that as I was talking, it actually kept changing what I was saying based on the context of what I said. So it does work with Brexit if there's less noise in the room. All right. And I always use that as an example of how quickly we're updating our models. So literally, a couple of weeks after Brexit became a term that people were using, you could run the speech API or the natural language API, and we would recognize the term. All right. And then we come to one of the most fun APIs that we have, which is the Cloud Vision API. You saw a little bit of a demo during the keynote. The Visual API does something that is almost like magic. There's been many years where people have been trying to understand what's the content of images, right? And for example, when Google first introduced image search, it was incredible, right? That you could actually type dog, and it would give you a lot of pictures of dogs. How did we know that those pictures were of dogs, right? Maybe someone naive may think, well, if the website says dogs, probably all pictures there are from dogs. But really, I mean, the pictures could be of anything. So what was really happening behind the scenes is that we were building very sophisticated image recognition models that could actually understand a lot of different categories of entities. So today, with the Vision API, we allow you to detect faces, landmarks, logos, text, and more. It's accessible through a REST API, so all you have to do is send us your image, or if your image is already in GCS, just send us the URL to the GCS location. And yeah, it basically will return a JSON response with a lot of really cool information about your image. So these are the kinds of things that you can get. You know, you can detect faces, emotions, whether someone's happy or sad or surprised. It can detect labels, like, you know, this has a man, and it has the ocean, or it has a church, or it has children, etc. It can detect text. So for example, if you have an application where people can take pictures of a receipt, say for a loyalty program, we could actually detect exactly what text is in there, so you could process that. It can detect logos, so very useful for advertising. It does safe search, incredibly useful for any website that you have that has user-generated content. You can automatically detect, using the same models that we use at Google, whether the content is inappropriate because of violence or pornography or something like that. And it can also detect landmarks. So let's take a look at how that works. So, so this is, you know, the Cloud Vision API landing page. So you can actually use it, and you can try it out with any images that you have. So we're going to try it with a couple of images so you get a sense of how this works. So first, obviously, the internet wouldn't be the internet without cats. So we can try a picture of a cat, and predictably, we do identify that it is a cat with 99% probability. Of course, we also tell you that it's a mammal, a vertebrate, that it has whiskers, et cetera, et cetera. So we're actually pretty sophisticated. In many cases, we can even tell you what kind of cat it is, what kind of dog it is, et cetera. Say I wanted to frame this picture of a cat, of a kitten, and put it in my room, and I wanted to, you know, have some matching furniture to go well with the picture of a cat. We can even tell you, you know, what are the dominant colors in the picture. Essentially, what we're returning when you call the API is a JSON response with a lot of useful information that then you can process in your application. So let's take a look at another image. This is going to be an image of children. So we have 4 children. So we can actually detect not only their faces, but we can also detect their emotions. So if you can see that behind the green, you know, the green squares, you'll see that they're mostly surprised. So we're basically saying, you know, with a very high likelihood, the kids are surprised. We can also tell you a lot of things. I mean, the reason we have boxes is that we can tell you a bounding box. If you have an application that needs to crop those faces, you can do that. We'll tell you even the position of the eyes, the mouth, the ears, the nose, etc. Let's take a look at another image. So this is going to be an image of a bottle. So predictably, it tells us that it's a bottle, but even more predictably, it tells us that it's actually a Coca-Cola bottle. It can also tell us, I mean, if we actually search for logos, it can tell us that it is a Coca-Cola logo. And if it was a picture that had other soft drinks, it would also tell us that. And in fact, let's take a look at that. So take a look at this picture. It tells us it's a drink. And it detects the logo of Fanta, Coca-Cola, and Sprite. Now, why didn't it detect the Pepsi logo? Because it's partially obstructed, and the model that we used in this particular case wasn't able to recognize it. But you know, the more images you have to train your models, the more accurate models become. Let's take a look at another image here. We're going to look at a book. So interesting thing is that we also do optical character recognition, or OCR. So if you look at the text, take a look at it. It did a pretty good job recognizing the text, Special Rehearsal Edition, Harry Potter, et cetera, et cetera. And you can then combine the output with the natural language API to detect entities, just like we're doing here. So you know, it is very powerful. I mean, it allows you to do a lot of really cool things and a lot of different applications. We have tens of thousands of customers using the Vision API today and doing all sorts of interesting applications. One of those customers is Wix.com. They're a company that allows you to very easily create new websites. So what do you do when you want to create a website, say for your company, for your organization, for your personal use? One of the first things that you want to do is put some cool images. So Wix had the problem of how to allow users to search among millions of images, both stock images and user-generated provided images, how to find images of something that you're interested in. And what they're doing is they're using the Vision API to essentially automatically classify all those images. We tell them programmatically, what are the labels of those images, and then that makes it simple for their users to search for images to use on the website. So basically, all images are searchable. They can also do face detection. So if you want to put a picture of a kid smiling, you can very easily find a picture of a kid smiling because the Vision API allows you to do that. So there you go. Here's our APIs. So we talked about the natural language API, translate API, Vision API, and speech API. So all built using Google models and all accessible to you through a very simple API. So with this, you get a sense of the different types of technologies that we have. So we talked about TensorFlow, which allows you to build models. If you're a data scientist, data engineer, you're a statistician, you want to build the models down at the lowest level, you can do that and run them in mobile devices, on the web, on the cloud. We talked about cloud machine learning, which allows you to do all of that, but in a much simpler environment with the full power and scale of the Google Cloud. And we talked about the machine learning APIs. There's a lot of different links, of resources. All of these technologies are available for you to try today. Try some of our code labs. Try them, at work, at home. You're going to find out that the power of machine learning is incredible, and you can use it today. Thank you, and enjoy the rest of the conference.